All right, so today we move on to lesson 3.6, multiply matrices. Pause the video and solve the problem of the day. So in 3.5, we dealt with adding, subtracting, scalar multiplication. 3.6 is dedicated solely to multiplying matrices, multiplying in general. Not scalar where there's a number at front. So if I tell you A times B, that equals AB, but it only works if the number of columns of A equals the number of rows of B. So if you remember, and actually I might slide these down. Okay, so if you have an m by n, the dimensions for A are an m by n, and B you have an n by p. Do you see how the number of columns, RC, rows by columns matches up with the number of rows of the other one? Do you guys see how they both have an n? Well, if the middle number repeats, the number of columns of A and rows of B, the kind of matrix it will form is an m by p. And where did I get that from? Do you see how n repeats? So what's left? M and p there. All right, so let's start off with example 1. That says state whether the product AB is defined. If so, give the dimensions of AB. I have a 5 by 2 and a 2 by 2. Always underline this number and this number. So the number of columns of A matches up the number of rows of B. Yeah, that's going to be 1. It's defined, actually. I'm just going to type it out. What I will have for my dimensions is a 5 by 2. So what's underlined goes away. We take the two other numbers. All right, so I have a 3 by 4, so underline the 4. Then a 3 by 2. Do you see how 4 and 3 do not match up? So this one is not possible or undefined. Can't actually multiply them. Let's try the last one here. We have a 3, 4 by 3, 3 by 2. These numbers are exactly the same. So yes, it's defined. It's going to be a what? A 4 by 2. So that's once again how we determine whether or not you can multiply. And honestly, every multiplication problem I do, I first look at the dimensions to double check that before I go any further. All right. Now, when we're multiplying matrices, I have a key concept for a 2 by 2. We start with that, but not everything is a 2 by 2. If you notice here, what I always like to do, and I still do it till this day, the first matrix, you always just do the rows. The second matrix, you always do the columns. So you'll see when I do a problem, I'm actually going to draw that there. So we go this way and this way. So I do A times E plus B times G. So we're moving in two directions here. A times E, B times G. That'll be the first number. Once I do this row, I'm going to move over to the next column. I do A times F plus B times H. So I do this column twice. I do the column, or excuse me, I do this row twice. I do the row with this column. Then I do this row again with this column. So I do all of the columns with the first row until there's none left. Once I'm done with all the columns, I go down to the next row and do the columns. So let's see how this works. And I mean, I know we could multiply example 2 out, but let's work on practicing the dimensions and whatnot. All right, so I have what? 2 rows, 2 columns. So this is a 2 by 2. And here I also have a 2 by 2. And just to get practice with, can we multiply them, yes or no? These two numbers match up. So lo and behold, it's going to give me what? A 2 by 2. All right. So let's go about getting ready to multiply. All right. All right, so what I have here, once again, the first one, I always want to draw my left or right arrow. Second one, I always want to draw my up-down arrow. First matrix, you solely do the rows. Second matrix, you always do the columns. And actually, maybe I'll do this down here. I don't think I'm giving myself enough room to write everything out. All right, I'll just start down here. All right. So I go this way and this way. So 2 times 1 plus, go over in my row. So I did this and this. If I go this, I do this. They match up. You're not distributing them. You're looking at how they match up. 2 times 1 plus -3 times 3. That'll be my first number. Now, I did this row in this column. I do all the columns on the right until I am done with the same row. So I did this row with this column. But if you look, it's like a pattern, right? I still have this one left. So then when I move over one, it's going to be the spot to the right because I'm moving my hand over here. So do 2 times -4. 2 times -4 plus -3 times -2. So 2 times -4 plus -3 times -2. We'll simplify them in the end. I did these 2 columns with this row. So I'm done with this row. I go down a row. Now I do the same 2 columns again. 1 times 1 plus 5 times 3. And then I do this column, 1 times -4 plus 5 times -2. Now this is my matrix. I mean, I gotta simplify them. It's a 2 by 2, so I'll get my numbers in the end, 4 numbers. But let's simplify first by multiplying. So the top left is 2 minus 9. The top right is -8 plus 6. Bottom left is 1 plus 15. Bottom right, -4 minus 10. Which now finally gives me my 2 by 2 of this. -7. I'll do it down here. -7, -2, 16, -14. And that's actually my matrix. That's my answer. So here's my 2 by 2 matrix I get with multiplying. Like I said, it takes practice. I promise it gets easier as we go. You just got to get some practice with it. Now, is multiplication commutative? Commutative means we could switch back and forth. The answer is no. It is not. It will only ever work one way. So do you know how like 3 times 2 is 6? If I flip it, 2 times 3, it's still 6. That's not the case for multiplication. It's very, very important that you know that. You have to multiply in the correct order. All right, so I have some more examples here that I want us to practice. All right, find the product. If the product is not defined, state the reason. Okay, so let's start off. What do we have here? Let's name the dimensions. This is rows by columns. So I have a 1 by 2. And this is a what? A 2 by 1. If I see they both have that 2 in common, right? So in the end, I should make a 1 by 1. Does that make sense? So our arrows, this one's always the rows, this one's always the columns, second one. So this one's actually going to be pretty easy. Like I said, it's nice to know the dimensions to know where you're going with the problem at first. All right, so we do these 2 numbers, add these 2. So 3 times 5 plus -1 times 7. I'll do more work down here since I don't give myself a lot of room. So it gives me 15 minus 7, which will give me 8. So I wanted to show you other multiplication matrices where it doesn't equal the same thing, like a 2 by 2 times a 2 by 2. Lo and behold, gives me a 2 by 2. But this one, this has one single number. So you need to know the dimensions to sort of know where you're going with the problem, because it's not always the same. All right, let's try the next one here. So this is what? 2 rows by 1 column. So it's 2 by 1. This is a 1 by 2, which should make a 2 by 2. So I can't actually multiply. It is possible to make a 2 by 2. All right. For this one, once again, this goes left to right. I always draw the arrows. I always use my fingers to show rows and columns here. All right. So here's what's going to happen. I go this way and this way. Do you see how when I go through my row, there's only a 1? And when I go this way in the column, there's only a 1. There's going to only be one number in each spot. So I do 1 times -2, which is just -2. Are we okay with me just writing it? I did this and this. There's nothing else. So I stay with my row. I move over a column. I always move over my columns first. That's my pattern here. So I'm going to do 1 times 1, which is just 1. Go down a row to this column and this one. 4 times -2 is -8. Then 4 times 1 is 4. And this is my 2 by 2. So once again, it's very important not only to check the dimensions to know whether or not you can multiply it, but it gives you a guideline of what your end product should look like. All right, let's try another set here. Find the product. If the product is not defined, state the reason. All right. So what do I have here? I have a 2 by 2. And this one is a 1 by 2. Let's look at those numbers that repeat. Is this one possible? No, it's not possible. It's undefined. Why? Because these middle numbers do not match up. And this is the proof. This is like the reason why it's not, that it will not work. Okay? So you don't have to show any work other than show me the dimensions and underlining them. All right, so let's see this next one. So what I have here, 2 by 3. This is a 3 by 2. Yes, I can multiply them. What am I going to get? I'm going to get a 2 by 2 in the end. I'll just type that down here. All right. So let's try this next one. Draw arrows this way. Ones go up and down. So let's see what I get here. It's okay, I'm going to multiply as I go. So I go this way. So I'm going to do this and the 9, then 3 and the 4, and then 0 and the -2. I'm going one number at a time, not the same number each time. So 1 times 9 is 9, plus 3 times 4 is 12, plus 0 times -2 is 0. Now I did this whole row and this whole column. I always move over to the next column before I move on. So I'm going to do 1 times 1, which is 1, plus 3 times -3 is -9, plus 0 times 4 is 0. So you see how I do this row with this column and this column. When I move over to the second column on the right, I went from here to here because I went from here to here. All right, let's keep going. Then I do this row with both columns. 2 times 9 is 18, plus 12 times 4 is 48, plus -4 times -2 is +8. Now do the same row with the last column. 2 times 1 is 2, plus 12 times -3 is -36, plus -4 times 4 is -16. Let's see what we get. All right, so let's write a final answer for 2 by 2. We get 21 minus 8. Then we get 74. We get a 50. That's my final answer. It's my 2 by 2. All right. Last example here. I'm actually going to just show the work for you for this, but I want you to try it first and pause the video if you need to. But I want you to do order of operations here. Check your work, what I have here. You see here you subtract first, and then you multiply and you get this. Here you multiply first and then subtract. But do you notice something? Make sure you copy this down and try it yourself. You get the same matrix in the end because it's the distributive property. You could distribute A to both to get this. So you get the same matrix in the end. Make sure you copy that down and take the time to make sure you understand it. All right, that's it for today. Hold on one second, gotta switch back over here. So homework today, problem of the day, and then complete 2 problems on assignment 2, numbers 1 and 10.